We've looked at solving exponential equations by changing them to log form, but what do you do if you have two different bases and exponents on both sides? Basically an exponential equation equal to another exponential equation. Well, there's more than one way to approach this problem, but let's look at the first way. One way is just to take the log of both sides, and I can just use log base 10, so I'm just going to write log of 4 to the x plus 1 equals log of 5 to the x minus 3. Then I can take the exponent and move it in front of the log using our, what I call the rainbow rule, or I think it's probably called the power property. I'm not sure what it's called exactly, but we'll take the quantity x plus 1, being careful to use parentheses, times log of 4 equals the quantity x minus 3 times log of 5. Now at this point I could do one of two things. I could divide both sides by either log 4 or log 5, or I could go ahead and distribute both logs to the respective parentheses. I think I'm going to go ahead and do the distributing method and then show you in a second example another method. So I would multiply log 4 times x, and I'm going to put a little time symbol to so that you realize that this is two separate numbers. Log 4 times x plus log 4 times 1, which is just be log 4, equals log 5 times x minus 3 times log 5. Now at this point we have an equation. Just think in your head, this is like saying, let's pretend the logs weren't there. This would be just saying like 4x plus 4 is equal to 5x minus 35 or something. Okay, so we're just looking at, we've got two terms with x and then we've got two constant numbers. So remember that log 4 is just a number. It's some number, it's the number that I have to raise the base of 10 to in order to get the number 4. So it's some number between 0 and 1. Log 5 is just a number. 3 times log 5 is just a number. So these are just numbers. And at any point in this process, if you are uncomfortable with just looking at that word log, you can change this to a decimal number and substitute it in the problem and continue the problem using decimals. However, do not round in the middle of the problem. So continue using the exact decimal as you progress through this problem. But I'm going to use logs because I want you to recognize that, to try to be comfortable with this. Now what I want to do generally when I'm solving for x is I get all the terms with x on one side of the equation and all the constant terms without an x, on the other side. So I'm going to subtract log base 5 or log of 5 times x from both sides, and I'm going to subtract log of 4 from both sides. So I end up with log of 4 times x minus log of 5 times x equals negative 3 log of 5, negative 3 log of 5 minus log of 4. Now what do I do when I have two terms with x? Well, if I go back to my little example over here, I would have had 4x minus 5x equals negative 4 minus 35. If I have 4x minus 5x, I just say 4 minus 5 times x. In other words, negative 1x. Here it's not quite as simple, but I still do log of 4 minus log of 5 times x. I could basically factor the x outside of a set of parentheses. So I have log 4 minus log 5 times x equals negative 3 log 5 minus log 4. Now I want to get x by itself, so whatever is multiplied times x, everything in this parentheses, I divide by that on both sides of the equation. So I end up with x equals negative 3 log 5 minus log 4 all over log 4 minus log 5. And then I put this into my calculator. So let's take a look at my calculator here. Where is the calculator? Okay, when you put this into your calculator, this is what entering all that into there. Notice if you don't push Control Enter, you get this kind of a weird thing here. And I wanted to show you where this comes from. I'll show you where this comes from in a minute, but then if you do the Control Enter, you get the number 27.85, and you can check that back in the original equation to show that does indeed work. Maybe I should do that. That's always a good practice to do that. So I say 4, raise that to the power of this number plus 1, and then check out, that's the number I get. Then I try and do 5 and raise that to the power of this number minus 3, and I should get the same thing. There we go. It makes me feel very good. Now let's talk about where in the world did this come from. I just want to show you this because this is actually a really good review of our log properties. Okay, so this is what your calculator did. First of all, here's how we entered this in. I didn't write the base 10 just to make it a little less busy looking, so those are base 10 logs. This is the way I originally typed it in. If you multiply both the numerator and the denominator by -1, which is a perfectly legitimate thing to do, notice that makes both of these positive now, and it switches the order of the subtraction. Instead of log 4 minus log 5, it would be negative log 4 plus log 5, or the same thing as log 5 minus log 4. Using our log properties, I can do the rainbow rule in reverse, and instead of bringing the exponent out front, I can put it back on the 5, so this would become log of 5 to the third plus log of 4, and then using our subtraction log property, this would become log of 5 divided by 4. Because these two logs are added, I can multiply their arguments, so that becomes log of 5 to the third times 4, which is 125 times 4. And this is log of 5 over 4, so that becomes log of 500 over log of 5/4. So all of this simplifies to this form. So that's why the calculator did that. It just automatically simplifies that for you. So it's kind of an interesting thing to see how your log properties at work there. So I just wanted to show you that. So going back to our answer, I didn't actually write the answer down, so let me write that down. If I can find my stylus, there it is. So the correct answer is 20, oh gosh, what was the correct answer? I do need to go back. Well, I think it's 27.8503, but you saw it earlier in the video, so if that is not correct, just whatever the calculator said a minute ago. For some reason, I can't get my calculator to come back up on the screen at this moment. So there we go. There is how to do that problem one way. Now, I want to show you a second way. And this is kind of using a little more of a little cleverness. It might help simplify. And I'm also going to show you, too, how you can insert some decimal numbers if that makes you more comfortable. So let's just start out to where we were at. Well, let's start the original problem. X to the 4 plus 1 is equal to 5 to the x minus, 4 to the x plus 1. Dyslexic speaking there. 5 to the x minus 3. Now instead of using log base 10, I'm going to use log base 4. Log base 4 of 4 to the x plus 1 equals, now I have to use log base 4 on the other side. I can't use different log bases on both sides. Just remember that. Log base 4 of 5 to the x minus 3. Now, if you look at this right here, hopefully you'll recognize, oh, these bases are the same. Log base 4 of 4 to the x plus 1 is just x plus 1. If you bring the x plus 1 out front, you can see that it would be x plus 1 times the quantity log base 4 of 4, and log base 4 of 4 is just 1. So this whole thing simplifies to just x plus 1. Now I still have a mess on the other side to deal with, but it's maybe a little bit less of a mess. So now I'm going to bring the x minus 3, and then this is log base 4 of 5. And remembering that I can't do log base 4 of 5 sometimes on my calculator, I'm going to rewrite that. X plus 1 is equal to the quantity x minus 3 times log of 5 divided by log of 4. Okay, so there's that there's a little fraction I have to deal with. Instead of leaving it like that, I'm going to change that to a decimal number. So if I do that on my calculator, I will get, okay, there's my answer, 1.6096, and obviously that's rounded, so I want to keep that on my calculator for future use. So I'm going to go back to my other screen that I was on, if I can find it. There we go. So this is x plus 1 equals x minus 3 times the quantity, 1.6096. Now I'm not going to keep showing you all the calculator stuff I'm doing. I'm just going to go ahead and simplify. So this is x plus 1 equals 1.6096x minus, and then 3 times that would be 3.4828. Now I need to subtract the 1.6096x from both sides, so I have x minus 1.6096x equals negative 3.4828 minus 1. So notice I subtracted 1 from both sides, and I subtracted this quantity from both sides and this quantity from both sides. Looks like I'm going to need to kind of go up the top. So notice here I have 1x minus 1.6096x. 1 minus 1.6096 would give me negative, oh, I think I left a decimal place out. Oh shoot, where is that? Nope, that's all right. Something's odd about my work here. I'm trying to figure this out. I figured it out. I forgot the 1 in front right here. There's a 1 here, there's a 1 here. So it's 1.16096. 1.16096. Okay, so when I do x minus 1.16096, that gives me negative 0.1609x equals, and then on the other side, negative 4.4828, because it's negative 3 minus 1. So then all I have to do to find x is equal to negative 4.4828 divided by negative 0.1609, and x ends up being the same thing that we got before. That's the 27.8503. And for some reason I have a question mark next to that. So it might be a good idea for me to do a quick calculator check on that and get back to you. And you could also double check the work on your calculator. Okay, I double checked, did the work on my calculator. Notice that I copied and pasted the numbers. I didn't ever round in my intermediate steps, and there is my answer. And that's why when you check your answer, you can get exact values. So hopefully that gives you some alternative ways to do a problem like this. Maybe that'll help you out. There's my phone. I'd better go. Happy computing.